So, if you're watching this, you want to learn about a different way to do the quadratic formula. It's actually not the quadratic formula, but I'm just going to show you a shorter way. And you can use whichever you like. Let's get after it. Here we have a quadratic equation. This is factorable, so normally we would do guess and check. We would start this way. Two numbers that multiply together, add together to 8. We're just going to ignore the sign for now. Okay. To find actual answers, we actually take the opposite sign. So let's do this. Let's leave the sign there for now, and I'll make the change later, and you'll see what I mean. So we would start with 12. Two numbers multiply to 12, add to negative 8. What just happened? So we would try like, let's see, negative 4 and negative 3. Nope. Because they add up to negative 7. And I would try negative 6 and negative 2. Yup, because they add up to negative 8. And so then I would factor these, solve, and then x equals 6 and x equals 2. But what if we started here? So, and we're going to switch the sign. The sign is the opposite. The sum is 8. Well, if I'm picking two numbers from 8, if you think about what is the shape of the parabola? So it crosses at x equals 2 and x equals 6. Okay, here's our axis of symmetry. These points are the same distance away from the axis of symmetry, which means it's kind of like finding the average, right? So if I have two numbers that add to 8, that means they are the same. Those two numbers are the same distance from some average. So what's the average of 8? Well, that's 4. So I have two numbers, right? But they multiply to 12. And they're the same distance. So one is to the right of 4, and one is to the left of 4. And u is our distance from the average. So when I multiply these out, I get 16 minus u squared equals 12. Well, I can solve for u squared. I get 16 minus 12 equals u squared, which is 4. And when I take the square root of u, I get plus or minus 2 equals u. So my two answers are 4 plus 2 equals 6, and 4 minus 2 equals 2. And these are the roots. I didn't have to factor because I switched the sign. You notice that this is positive 8. Does this work in every case? Did we just eliminate the need to guess and check or plug it into a complicated formula? Let's try again. Let's take our previous example. Now we can't factor it. I changed this from a 12 to a 13. But let's just try our method. So my two factors have to sum to negative 8. So my zeros, my solutions, remember when we solve, we set it equal to 0, and then our factors, the signs actually change. So my zeros should add up to the opposite of negative 8, which is 8. So the average of 8, I'd take 8 divided by 2, that's 4. So this is just like what we did last time. But my two zeros, they should multiply to give me 13. And so I have 16 minus u squared equals 13. This can be positive because when we square it and we take the square root, we get both positive and negative. So when I multiply this out, I get 16 minus u squared equals 13. Solve for u squared. U is plus or minus radical 3, so I take the average, 4, plus or minus radical 3. This is my answer. These are the two zeros. Okay? You should recognize this. This is the part, this is b over 2. And so what is 16? Right? If I square this, I get b squared over 2 or over 4. That's 16 in this case. 8 squared over 4 equals 16. This is from completing the square. It's not that this method it comes out of nowhere. This is what we already do. We already complete the square. So this is telling us instead of just memorizing a formula, we're finding, that's a bad drawing. Sorry about that. We're finding the 2 points on the parabola that cross the x-axis based on the axis of symmetry, because we're finding the average distance to the right and to the left of our axis of symmetry. That gives us our zeros. What if our answer is complex, meaning it doesn't have any real solutions? Let's compare it to the quadratic equation. So let's say we have a quadratic, the quadratic formula. Let's say we have a quadratic equation where a is 1/2, b is -1, and c is 2. And I'm going to use a quadratic formula to plug these things in. So I have -1 plus or minus the square root of -1 squared minus 4 times 1/2 times 2 all over 2 times 1/2. X equals 1 plus or minus the square root of 1. This is 2 times 2, which is 4, minus 4 over 1. So it's x equals 2 times 1/2 is 1. 1 plus or minus the square root of -3. So x is 1 plus or minus, let's see, I times radical 3. That's the quadratic formula. My only issue is that our method doesn't work if a is not 1. So let's rewrite this and get rid of the fraction in the front. We may have a fraction for b or c, or not. So in order to get rid of this, we multiply the whole thing by 2. I get x squared minus 2x plus 4 equals 0. What's the sum? So the sum has to be the opposite of b, which is 2. Okay, so what's the average of 2? That's 2 over 2, which is 1. So I have 1 minus u times 1 plus u. That has to equal 4. That's my product. They equal 4. So let's multiply this out. I get 1 squared minus u squared equals 4. Solve for u. Basically, these just switch places. I get 1 minus 4 equals u squared. That's -3 equals u squared. You can see where this is going. I have the square root of -3 equals u. That's plus or minus. My answer is 1 plus or minus the square, 1 plus or minus I times the square root of 3. These are my zeros. I use this here, right? This tells me, this gives me the product. These are the numbers that yield the product. So that means these 2 points on the graph, these are my x values. They yield the solutions, the zeros. Even though they're not real, I can still find them using this method here. So if you just want to memorize this, that you're just averaging b and then finding where that average, those 2 points that are the same distance from their average, where they equal c, right? This is c. Whoopsie daisy. This is c. Okay. This is b over 2. This is b over 2. And there you go. And you're good. I hope this is helpful. If this seems too complicated or you're not quite sure how this works, don't do it. Stick to quadratic formula. Stick to guess and check. Stick to completing the square even. This is fantastic. Completing the square is a fantastic method. This is basically the shortcut of completing the square. So if you have any questions, you know how to get a hold of me. Good luck.